In this lesson, you will learn how to solve systems of equation using the substitution method. The steps for substitution, which I have in my notes, are you need to isolate one of the variables, so you need to solve for one of the variables, and then plug it into the second equation, solve for the variable, and then go back and plug it into either equation to solve for the other one. So you will be done when you have a value for x and a value for y, and I like to write my answers in ordered pairs. So let's go ahead and get started. For number 1, we have y equals negative 3x plus 5. For this first equation, y is already by itself, so it's already solved for. So you're going to take what they're saying y is, which is this. You're saying this is your y. You're going to plug it into this y. So we have 5x minus 4 times y. Y is negative 3x plus 5. And you're saying that that equals negative 3. So now I just need to solve this. So distribute. Negative 4 times negative 3 is a positive 12x. Negative 4 times 5 is negative 20. Okay, combine these like terms. 5 plus 12 is 17. Add 20 to both sides to get 17x equals negative, no, that's a positive 17. Divide by 17. So I'm getting x is 1. Now I just need to find y. You can plug this into either equation, but it's definitely easy to plug it into the one that's already solved for. So I have y equals, I'm going to plug it into the first one, negative 3 times x, x is 1, plus 5. This is negative 3 plus 5, which is 2. So write it as an ordered pair. You will get 1 and 2. That's your final answer for this one. So we have 1 and 2. For my second equation, I don't have y by itself or x, so I need to solve for isolated. It's always easier to isolate the one that doesn't have a coefficient or number in front of it. So in this second equation, let's bring 2y to the other side by adding 2y, add 2y. So I'm getting, let me draw a line here to separate this first problem. So I'm getting x equals 11 plus 2y. Okay, I have this by itself, so I'm saying this is x. So this is going to go and replace x into the other equation, which is the first one. So I have negative 7 times x, which is 11 plus 2y. Then write the rest of the equation out. Distribute, so we have negative 77. Negative 7 times 2 is negative 14. Y minus 2y equals negative 13. Combine these two like terms, so I have negative 77 minus 16y equals negative 13. Add 77 to both sides. So we have negative 16y equals, yeah, we need to subtract this. 7 minus 3 is 4. 7 minus 1 is 6. So it looks like 64. You can go ahead and use your calculator for these because some of the numbers turn out to be big. Okay, divide both sides by negative 16 to get y equals negative 4. So I found y, I need to go back and find x. I'm going to plug it in here. So here I said x equals 11 plus 2 times y. Y is negative 4. So x equals 11. 2 times negative 4 is negative 8. 3. So my solution here is 3 and negative 4. Because x is 3 and y is negative 4. Okay, let's work on our third problem. So here I need to get one of these by itself. What I'm going to do is get the y by itself. So I'm just going to add x. So I get y equals 3 plus x. So again, I'm going to take this and I'm going to replace the y in the first equation. So I have negative 3x plus 3 times what I'm saying y is, which is 3 plus x. And this should equal 4. So I have negative 3x plus 9 plus 3x equals 4. Negative 3x plus 3x will cancel, so I have 9 equals 4. 9 does not equal 4. So when this happens and your variable has canceled out, the answer is no solution because this statement here is false. So this tells me these are parallel lines. We went over it in the previous section. Parallel lines have no solution because they will never cross. For the fourth problem, I already have y by itself, so I'm going to take this and replace this y. So I have 3 times 2x minus 4 minus 6x equals negative 12. Distribute, you get 6x minus 12 minus 6x equals negative 12. 6 minus 6 is 0, so these will cancel out. So I have negative 12 equals negative 12. Yes, this is true. Negative 12 does equal negative 12. So when this happens, this is when we have infinitely many solutions. This is basically saying this is going to turn out to be the same line that is going to cross infinitely many times.